Okay, today we're talking about the Pythagorean Theorem, not the Pythagorean Theorem. I even had to think of how people say that wrong. It's the Pythagorean Theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the length of the legs. That is the Pythagorean Theorem. It says that the legs A plus B, when you square them, are equal to the length of the diagonal squared. The leg in a right triangle is the side adjacent to the right angle. Okay, so the legs are always going to be those touching the right angle sign, and the hypotenuse in a right angle in a right triangle is the side opposite the right angle. So it's always the side that does not touch the right angle sign. So that sign. So find the length of each hypotenuse to the nearest hundredth. I told you above that a squared plus b squared equals c squared is the Pythagorean theorem. Okay, so it doesn't matter on your legs which one is A or B. It just matters that you label the two sides that touch the right angle sign, A and B, and the other side that's adjacent, meaning, or opposite, meaning it doesn't touch the right angle, C. So, in for A, I'm going to put 5. In for B, I'm going to put 4. Then I'm going to simplify the powers. 5 squared is 25. Plus 4 squared is 16, and I'm just going to bring down my c squared. And then I'm going to add 25 and 16 and get 41, and again bring down my c squared. Now we're going to solve for c. Remember that lesson where we were talking about area equals side squared, and to undo the square we take the square root of both, and s squared is s. That was a good introduction for today's lesson, because in order to find what c is, because it's squared, you have to take the square root of both sides. The square root of c squared is c, and then we have equals the square root of 41. It says to the nearest hundredth. So we can type 41, hit our square root button into our calculator, and we will get 6.40 when we round it to the nearest hundredth. So now we're going to find, or use the Pythagorean theorem to find the third side of the right triangle given these coordinates. So we have 1, -2, so we're going to mark that first. Man, they make this thing real difficult, because that is about right there. And then they have 1, 7, which is about right there. And 13, -2, which is about right there. So then we connect these. Okay. So this is our C, our A, and our B. So this was 1, -2. This was 1, 7. And this was 13, -2. Now we have to see how long B measures and how many units A measures. So for B, because it's on up and down, we're going to be looking at our y coordinates, because our y is up and down. Okay? So from 7 to 0, there are 7 units, right? And then from 0 to -2, there are 2 units. So we have 9, because from 7 down to here is 7 units, and then we have an additional 2 units. Then, so this is our B. Our A, we are going from left to right, so we're going to look at the x coordinates, and we're going from 1 to 13. So the difference of 1 to 13 is 12. Okay? So A squared is 13, B squared is 9, then we're going to square root, and we're going to get 169 plus 81, so we're going to simplify our powers, and then we're going to add and get 225, so to get 225 we did adding, And then we're going to find the positive square root. And in order to undo squares, we have to take the square root. So the square root of c squared is c. The square root of 225 is 15. So c is 15 units long. Okay. Solve for the unknown side in the right triangle to the nearest tenth. So we're going to use the Pythagorean Theorem, because that's what we're learning. And this can be a because we already have a b, and this is c. Okay, so in for a we're going to put 7 squared, and in for c we're going to put 25 squared. Then we're going to simplify the power. 7 squared is 49, 25 squared is 625. Now we have a two-step equation. I look to the side with the variable, look at my constant. It's being added to b squared. So the opposite of adding 49 is subtracting 49 from both sides. We bring our b squared straight down. 625 minus 49 is 576. And then to undo our square, we have to square root. The square root of b squared is b, and the square root of 576 is 24. So our leg is 24 something. I don't know if it's inches or what. What you should know, though, is your hypotenuse, your C, is always the longest leg of the triangle, okay, or side of the triangle. So if you're looking for A or B and you get a number that's larger than C, you did something incorrect. And if you are finding C and you got a number that's smaller than A or B, you did something incorrect. So let's put that. C is always longest side. That right there is an S. Two airplanes leave the same airport at the same time. The first plane flies to a landing strip 350 miles south, while the other plane flies to an airport 725 miles west. How far apart are the two planes when they land? So we have airport here. Okay, just kidding. We're going to put the airport here. The first plane flew south 350. The next plane flies west 725. And we want to know the distance between this point and this point. This is our right angle, okay? So this is C. So we need to substitute. Let's go ahead and say this is A and this is B. Remember, it doesn't matter which is A and B as long as you have the sides touching the right angle sign as your A and B. We have 350 squared plus 725 squared. 350 squared, 350 times 350 is 122,500, and 725 squared is 525,625. So there we simplified our powers, and now we need to add. When we add those two numbers, we get 648,125 equals C squared. Now to find C, we have to find the positive square root because it's a distance, and distance is always positive. But to find C, we have to undo the square by taking the square root of both sides. And the square root of 684,125 is 805. Okay? About, it's probably not exactly, but close enough. There's probably a decimal there. So, the planes are about 805 miles apart after they land. Go do 1, 2, and 3. I would suggest on 3 you set up a picture like we did for example 3 to make that a little bit easier and give you a visual.